So as a reminder, thank you. As a reminder, we're trying to provide a system. This is one of the system configurations of our distributed storage DC system, aiming to be a backup system for essential daily needs and also a daily system for integration to grid. And we're focusing on really reducing the DC growth by reducing the inefficiency of it, reducing the waste, and making it more standard. And that's being fueled by the standardization of USB. We've looked at the house model as well as commercial models in terms of installing battery packs connected to smart meters. The smart meter could trigger the battery pack to charge on demand. We're also looking at reusing existing batteries in the homes for backup generation here, for both daily and backup needs. A basic configures the system, pulls daily power from local solar if it exists, or night power or on demand, runs a DC network for lighting electronics, suitable for homes and offices and data centers. We talked briefly about the home model earlier today, and one of the algorithmic configurations is to set it to sort of pull peak energy, off-peak at night, or in this case surplus energy, use local solar. What's interesting, I didn't mention this morning, is with new fabric solar glass, it doesn't produce much energy, but it's quite good for putting into your local DC load, like lighting electronics. In this case, we configured it for peak. In practice, you could configure it for any demand type response, so leverage surplus to reduce a purchase agreement, or off-peak or renewables, or potentially link this to reducing peak load and contract prices. From the consumer, it's batteries, it's lighting, it's DC power, it's convenience and control. From the utilities, there's a whole hierarchy of benefits which can be configured using this as aggregated storage. From the network, it looks like bulk storage, but can be very targeted locally around local network needs, or grid backup needs, or wind coupled to reduce curtailment. Here's an example of a smart storage system. It sort of hangs on the wall. It can be without battery pack or leverage existing battery packs. This one's actually reusing electric vehicle component cells in the battery pack. There's about a kilowatt-hour battery in this configuration, which is actually all you need to do all your daily lighting electronics, peak load shift in a UK household. We've got various technology behind it. There's hubs and sockets and controls. We've also integrated meters, secure meters, I mentioned earlier. We have patents behind the variable DC architectures sitting underneath it. One of the patents just awarded this month, interestingly, Apple, the iPod inventor Tony Fadell also got a patent in a related smart socket area. So there's quite a lot of activity beginning in this sector. And it makes things like smart control work. If you have a smart control chip, you'll probably upgrade it to the next one, the next one, the next one. Whereas if it's installed in this system, it's persistent. You're not going to throw the system away because it's powering things you need. Therefore, it's got an opportunity to learn over time to automate. You need to basically observe homes in order to work out how to make interventions. If you go to the house audit today, you're limited by the set of technologies and choices and prices. You need to do real-time audits over time because new technologies exist in the future which make new decisions possible. As I mentioned, we're doing trials. We're very interested to do trials here in communities, in offices and homes, in new developments. And so I'm quite interested to continue talking about that, residential, community, commercial. Here's an example, apartment configuration, doing lighting and some electronics. I talked about mesh networking in terms of our local support for that. Here's an example for a hotel where essentially a battery's powering DC lighting, DC fridges, a whole DC environment at 20% of the energy compared to normal energy. There's a site in London, if anyone's visiting, there's a large commercial site, theatre, repairing all the lighting and office space in that environment. Things like desk clusters, using USB and multi-voltage to power desk clusters and hubs and getting rid of all the AC/DC cables. This is kind of interesting because it could be embedded at the Homer Miller steel case level in cubicles to reduce wires, reduce the need for high maintenance, and essentially it's all low voltage DC, so it's quite safe to install, similarly in classrooms. We're doing a showcase with ABB in Czech. It's an EU-backed project. It's just been funded by 12 million from Europe. I understand there's some corridors and new developments here, which could be quite interesting to do DC architectures and demonstrate some of these principles here. Talk briefly about the 3D modeling. So it's a very brief snapshot, again, just a reminder of the stuff Moixa is working on, just to separate it from some of the background data we talked about in the market this morning.
Simon,
thank you.